my grandson is sick too, so we're all getting it. All right, so in this part, and this is the last of these, God bless you. It's working with functions and doing operations on them. Now, we add them, subtract them, multiply them, divide them. The only time we have a problem is when we divide. And the only problem with the divide is you might have to change your domain around a little bit because you have restrictions in denominators. So we're going to start out with a couple of functions. We're going to find their domain together. We're going to add them, subtract them, divide them, and it might even look familiar. You might have done this and called it something different. We're going to take your functions. Sometimes you can do it right off of a graph. Sometimes you can do them right with equations. And all we're going to do is add them together, subtract them, divide, multiply them. But the first thing we're going to do is find their domains. We're going to find equations together. That's your f of g with x. We'll find the equation together. And then we'll do just different operations on them. It's kind of, you might have even done it with graphs. I think I put one with a graph on here. You might have done it like these and had to add them together. No. Okay. Okay, but they're not difficult. They look bad, but look how easy they are. Take one function, add it to the next. Take this piece, add it to this piece. That's all it is. And we come up with a new equation. That's all we do. Our main goal is to make sure that your domains are good. So first thing we walk through is we find any domain restrictions. Does this have any restriction in this domain for this function? What would that give me when I graph that? A line. Does this guy have any restrictions? So our domain is all real numbers. When we add them together, all it says is take function x and add it to function g. So you take whatever is in x plus, if you want to keep parentheses here for the time being, that's fine, add it to g. Now when we add, do we actually need those parentheses? No. The only time we need them is when we subtract or when we multiply. So adding them, you're just going to combine like terms. So you got an x squared, a 2x and a 2x gives you a 4x. Oh, I have the sheets over here. And a plus 1 and a negative 1 cancel out. So this is your result. When you add, it won't affect your domain. When you divide, it will affect your domain. Now, the only other thing you can do is sometimes we ask you to evaluate. It's the same thing when you do a composition of functions. Sometimes we say evaluate each one, do the f of g. Sometimes you were given this. So you had to find the equation for this. And then somebody gave you this. And they said, prove that your equation works. You plug the 2 into g. You take that result and plug it into x. Or you take the equation and you plug the 2 into that equation. So it's kind of the same thing. So we evaluate this when x is 2. So 4 plus 2. And if you want to check it, you can plug it into here. 2 times 2 is 4 plus 1 is 5. 2 squared is 4 plus 2 plus 2 plus 2 times 2 is 4. So that gives you 8 minus 1 is 7. And is that equal to 12? Yes. So if you're going to prove that it works, that's a good way to prove it. Evaluate it. All you have to really do is plug it into your final answer. If you want to make sure that you did it right, you can always do it together like that. Okay, good so far? All right, now normally we don't have a problem until we go to divide. have a little bit of a problem here with our domains. So under a radical, we know that you cannot have a negative. You can have a 0. So we take this and we set this greater than or equal to 0. I'm just going to use a little number line here. This one says, take this and set this greater than or equal to 0. This gives me a quadratic inequality. So a quadratic inequality, we find the roots for. So if we set this equal to 0 and find your roots, x squared equals 4, so x is equal to plus or minus 2, and we test. We test these guys, and we say we can use them as 2. And which way is my parabola opening? Which way is my parabola going to open? It's got the negative in front. Down. So my parabola is going to go like this. So where's my positives? Right in here. Agree? So on my number line, where do they overlap? What would be my domain? So if I put a negative 2 into this one, will that work? So 0 to 2. Good. And can I use 0 and can I use 2? Good. So there's my domain. Before I do any operations, I find my domain. And then I simply divide. When I divide, it looks like this. Now at this point, if you can simplify it easily, then simplify it. But if it doesn't simplify, just leave it like this. The only thing that's going to have to change, may have to change, is your domain. So we look in our denominator, because in a fraction we have a problem with the denominator. And the denominator cannot be 0. So do we have to alter our domain at all? If I put a 0 in here, this will say 4 minus 0, square root of 4. That works. If I put a 2 in here, it says 4 minus 4 is 0. Can I have a 0 in my denominator? So I have to change my domain. My domain has to say 0 to 2. I have to change my domain because we threw one more restriction in there. Now sometimes you don't have to change your domain. If you had, this one had a radical and this one was a line, and this one ended up in your denominator, you might just have to look to see what, well, even if, like, let's keep this a parabola. Say this was a parabola down here, not a line. If I did this, and my domain was 0 to infinity because of this guy, would I have to change my domain for this? Is there anything that's going to give me a 0 down here? Not a 0. What can I plug in there that'll change? A 2. I'll have to change that. What if I did this? I won't get a 0, right? Because I will not get a negative number out of this for this to become a 0. So if this was in my denominator, I wouldn't have to change my domain. Anything in my denominator with a minus here, and this could possibly become 0, I'm in trouble. A 2 or a negative 2, I got to take out of my domain. Negative 2 we didn't have to worry about because we didn't have one in there. But I would have to take out a positive 2. But if it looked like this, then my domain would be fine. So you have to take a look at which way this is going. Now the flip side of this says, take g and divide by x. Now remember your domain was from 0 to 2. What's going to change now in my domain? The 0. I can't use a 0. So my domain has to go like this. Okay? And if it helps, graph the final one and see what that looks like out there. Okay? The divide is the only one that really gives you problems. The multiply, it's fine. Only the divide gives you trouble. Again, sometimes we look for equations when we do this. So before we do that, we have to find the domain of both of these. Does this function have any domain restrictions? God bless you. No. Does this one have any domain restrictions? Can't be what? Or could I be 4?
No.
So I've got an inequality, right? Could I put a 4 in here? Could I put a negative 4 in here? Right? So use your rules. Set this greater than or equal to 0. It's not in the denominator, so I can have a 0, right? Okay? Now look, we have an inequality. Remember we talked about these. These are the ones that are the hardest ones because it looks like it's going to be 3 and negative 3, but 3 and negative 3 both work in there as well. But a 4 doesn't work in there, and a negative 4 doesn't work in there, because if you set this equal to 0, your critical values are negative 3 and 3, but you can use them. Which way is your parabola opening? Down. So where are your positives? Right in here. Aren't these positives these negatives? If not, put this in your calculator. Test to the left, test in the middle, test to the right. You're testing the value of your function. The value of your function is your y value. So this tells me my domain can only go from negative 3 to positive 3. Good? Now we're going to find this, the domain of this guy. That is the domain of this. Now we're going to find this equation. We're going to take G and we're going to put it into F. We're going to take this whole thing and plop it into that X right there. There you're going to get. So what happens when we square a radical? Couldn't takes the radical away. So the 9's will cancel out, and we'll be left with negative x squared. Now negative x squared by itself has no restriction, but because we started out with it that way, we still have to have a restriction. Okay? And if you needed to find it the other way, whenever you can simplify, simplify it. At this point, I can simplify this, so simplify it. If you're doing some of the additions of your functions, get them always down to simplest terms. Remember, we don't rationalize denominators in precalc, so that's a helpful thing. If you have a radical in your denominator, you can leave it there, unless it's going to cancel out, unless you have this. That will cancel. But if you have this, you don't have to rationalize, but you do have to watch for a domain restriction. Okay. We kind of lean more on the domains than we do anything else around here. So that's probably one of the reasons why precalc doesn't rationalize denominators. Because if we change the domain and then we rationalize your denominator, you kind of lost the reason why we had a domain restriction. This h of x came from two functions that we did this. See if you can come up with something that will give me a function f and a function g, that when I do f of g of x, I get this result. There's more than one way to do this. I want you to think about it for a minute. Yes. Well, take that test. That's on the. Take that test. That's on the top of that thing because there's a security guard in the hall. Anybody come up with two equations for me? Lily, what'd you come up with? Oh, so which is the x? And which is the g? Again, I'm sorry. Okay, so if we plug g into x, we get, good. Anybody do it differently? You're just kind of thinking it out, separating it. Does this one here, does this guy have a domain restriction?
By itself or
By itself. So there's nothing that I could put in for x that would give me a 0 down there. A 2. Good. I can't use a 2. So my domain has to jump over that 2. Okay? And the same thing happens, well, I have a 0 down here. So once I separate these, now I know what the two of them are. I'm going to have to take the 0 out of there as well. But before we did this, we didn't know what the two separate ones were. So now you're going to have to take a 0 out of here. Okay?
wait, why'd you take a 0 out?
Because once we separated it, this one can't have a 0. But we didn't know that before we separated it. We could only look at what we ended up with as a composite. We didn't know before we looked at it. I was going to wait till we did this, but this kind of says, does this have a domain restriction? Okay, so sometimes just think them out and then try them. Make sure they work. Okay. And the only other time you're going to see these, which I thought you might have seen these before, is with a graph. What they're asking you is just to find the value of y at 0 when x is 0. So you have to look at your f function. This is your f function. What is your value when x is 0? What is your value of y? 2. In the g function, when x is 0, what is the value of y? Negative 1. Okay, that's all you have to do. Take them right off the graph. When x is 1, what is the value at f? 3. In the g function, when x is 1, what is the value of y? 0. Excuse me. When x is 2, in the f function, what is the value of y? 1. When x is 2 in the g function, approximately what is the value of y? Probably like a half. Or 3 halves. When x is 3, what is the value of y in the f function? 2. And when x is 3, what is the value of y in the g function? 0. So if you're going to look at a graph, that's what you're looking at. Okay? but you